how do we judge whether a model will produce predictions that are reliable in terms of asset allocation? This is one of the most fundamental things in tactical asset allocation. We build quantitative models that forecast asset returns. How do we know whether the model is going to be reliable? Now, these models, we take an equity return and regress on information that's known in advance, or lagged information. The usual measure of the goodness of fit is the R squared. And it's really important that we understand what that actually means. Now, the R squared, the classic definition of the R squared, has to do with the amount of variance that you're explaining. So you can imagine an individual asset return, such as the S&P 500, and you know it's a highly volatile return. So it is moving through time up and down with a fairly large variance. When we fit a forecasting model, the variance is much smaller. And the fitted values, the forecasted values, through time look like this. The R squared measures the fraction of variance that I can explain. So another way of thinking of it is to think of the predicted returns, the volatility of those returns, divided by the volatility of the actual returns. So the models that we're going to work with have modest explanatory power in the range of 2 to 10%. So these models deliver explanatory power that is far smaller than perhaps what you're used to using in a classic regression. Now the key is that the R squared does not tell us how profitable the strategy is. What we really care about here is whether we get the direction right. So in September of 1986, or 1987, if the model tells us that there's going to be a small negative return, that's incredibly valuable information, because in October 1987, there was a large negative return. So even though the variance is a very small fraction of what actually occurred, we get the direction right, and this model tends to lead us to underweight the S&P 500. And that would have been a correct directional call. So often we use other measures, like the number of times you get the direction correct. Now the other thing about R squared that we have to be particularly careful about is that when we fit our model on our test sample, we have to be careful not necessarily to choose the model with the highest R squared, even though traditionally that's the way that we're taught how to do regression analysis. Indeed, if you just choose the highest R squared by searching through all the variables, you'll have a model that is destined to fail when you apply it out of sample. The key to making money in asset management using quantitative models is to have a model that works out of sample. So you can search the data to try to find the best possible R squared. But in doing that, you're probably putting variables into your model that don't work out of sample. So a good R squared in sample might lead to a bad R squared out of sample. The key thing is not the R squared, but whether the variable makes any economic sense to put in the model. And we use other metrics to try to evaluate these models. And sometimes I hesitate to use the R squared, but to actually look at the trading profit that this model actually generates in the out-of-sample period. That's the way to evaluate a model.